Good morning. We are Team Zeno Effect. Our team members are Sandra, Dean, and Sahar from Cal State LA, and Hu Chung Mo and Yu Ting Huang from Taipei Tech. Our coaches are Dr. Paul Lu and Dr. Pei Feng Tsai. In our observation, we discovered that employees currently performing assembly procedures can be helped in their job using a system that equips the employees with choosing the right parts and guides them through the right assembly process with the help of the cameras integrated in the system. This potentially reduces errors and speeds up the assembly process as a whole, and as a result increases the production rate in addition to removing paper waste created through data collection. To reach our goal of improving staff production and productivity, it was necessary to understand how our team could best aid both manager and employee. Due to COVID-19, this became an issue as we would normally be able to observe the employee and managers in their work environment for several days and then plan out our ideas as a team. However, this year we focused on what we already knew the issues were and how we could best improve. We learned there were 4 items we could help a company with. Those were logging into the system, part recognition, assembly process, and tracking.
The web interface consisted of a login page in which staff could either sign in with a username and password or through the team's technological improvement of facial recognition. Depending on the role of the person who logged in, the system would show one of the two interface designs, the manager's main page and the employee's main page. To aid employees with disabilities, this is where the team focuses on using facial recognition to log in, even though they too can log in using a username and password. The facial recognition was tested using various facial images. For one, it was tested using the camera abilities available to the laptop. Second, it was tested based on image files stored in the platform. And lastly, it was tested to see if the platform was smart enough to see the differences between a real person standing in front of the camera compared to a simple image placed in front of the camera. The facial recognition was also tested to see if the staff member would be recognized whether in shades, with a hat, or other items that could cause faulty or not recognition positive results. As a result, it appeared that staff member was unable to have any items that would cause a platform to read negative as it did not recognize the staff member.
The Assemble tab is where the team focuses most of their time as it contains the camera recognition of the part along with the assembling process. The system begins by having an employee place a part in front of the camera. The camera will determine if the part is accurate. If the part is accurate, the system will identify the part and instruct the employee to scan in the next needed part.
The object detection was trained and tested using the YOLO platform, a real-time object recognition system that can recognize multiple objects in a single frame. YOLO is short for You Only Look Once. YOLO recognizes objects very precisely and faster than most object recognition systems in the industry. This real-time recognition system will recognize multiple objects from an image and also make a boundary box around the object. It's easy to train and can be deployed in a production system. We tested the YOLO system by placing it in an environment where we simulated an employee picking the right materials for verification and assembly. As seen here, all the parts are to correctly correspond to the Lego pictures in the table on the right. A green check mark in the system means YOLO has verified the part is correct.
After the part recognition portion, employees are taken to the process in which video clips show the employee how to attach parts. The team creates various GIF files that would guide the employee through either the chair, house, or robot scanning assembly. The team can continue to add other GIFs and video assembly process guides to best aid the employee in the future. The video above shows a real-life example of how the employee would assemble a part after correctly identifying the needed part. Through scanning and follow the step-by-step video instruction on how to construct a project. In this case, it is a robot assembly.
The web design was developed through the computer languages known as Django, Python, Bootstrap, JavaScript, and HTML. Work on the code would take roughly 4 to 5 hours for about 8 weeks. Each week, the team would review and give improvement suggestions in addition to pitching on how to make the web application more user-friendly. The manager, when signing in, can see the dashboard, which includes the information on the inventory of each assembled item and the workload of each group in the assembly line. Details such as the percentage of completed items to the progress of current items is color-coded to highlight any trouble for extra attention. To add, the manager can see the staff they oversee along with their name, title, and other work-related information, such as group production rate. In each case, the interface is user-friendly and clear. Once the employee gets past the login portal, they are taken to their dashboard on their task assignment. On the left, they can toggle between 3 mock-up assembly tasks: the chair, house, and robot assembly. The complexity level represents the level of skill required for the assembly task. Each left tab comes with the inventory information and the assembling tab. In the inventory information tab, employees can see how much has been completed and what their targeted production is for the day. One of the interesting features of the system is the ability for managers and employees to communicate with each other in real time. The system has chat room functionality, which enables managers and employees to easily and effectively communicate with each other in real time and on the job. In summary, the team's web-based interface will allow for people with disabilities to best identify objects and get into the system that can aid them in their work. Similarly, managers will be able to track production hours and product completion easily, as they too have the same platform working for them rather than relying on primitive ways of gathering information and error-prone forms of tracking. Errors can be made and quickly adjusted using camera recognition on human faces and objects needed to complete a task or assembly. Furthermore, the system allows for streamlined communication and more information transparency. The code was produced to ensure there were no error codes as the manager or employee toggled between sections.
The table shows the real-world costs in the event the project would go live, attaching all the possible costs the company would need to take on as an investment in the interface, from camera to use facial and object recognition to the electronic devices the company may buy to help them use the platform from a stationary perspective to an on-the-go device such as a tablet. Last, it shows a small aspect of the coding and server resource allocation.
The design and implementation of our facial recognition platform system proved to be successful and possesses the potential to continue to positively impact companies such as SourceAmerica and agencies alike. The web platform is great for both employers and employees, aiding them in the assembly process through object and facial recognition. Finally, we would like to thank the following people for their aid throughout the project: